Over to you, Andy.
Right. Yeah, if you have questions, chat should work pretty well. I think I have my system set up here, so the chat's right in front of me. Are you guys seeing my presentation? Just make sure.
Yes.
Okay. All right. So my name is Andy Unterseher. I am a software architect for Don't Panic Labs. I also I lead our products team at Don't Panic Labs. I have about I've over 15 years of experience in the software industry. I have worked at Don't Panic Labs for over 10 years, so I've had the opportunity to design and build a whole lot of systems in that time. So that's kind of my current role, my professional career. You could follow me on Twitter. You might catch my like twice a year tweet if you're really interested. And then we also have a blog at Don't Panic Labs, which we try to provide some helpful content and things that we learn and do. And then just a little intro on Don't Panic Labs. Don't Panic Labs we're sponsoring because we like to give back to the development community. But just a little background so people know. We are a software development company that primarily builds products, and we build them both for ourselves and for external companies. So we work with a lot of companies in the Lincoln and Omaha area to help them basically come to us with a vision of a product, and we help them achieve that into working software. We also recently have started doing developer education as well. So we have some programs to help kind of transition people that are kind of technical but not in a technical position and help bring them into the workforce. So one of our main goals is to, help address the tech talent shortage we're having in Nebraska. We need more people to hire. I'm sure every company on this call probably needs more people to hire. So that's something kind of interesting. And if you're interesting, two people from our company recently wrote a book on lean software systems engineering. That's kind of a big focus in our company, is where we believe in software engineering. So it's something you could check out. Just a little quick agenda. I'm going to do a little background on why I'm here, why I thought this topic might be interesting. I'm going to, assume it's an Azure group. Everybody knows a little bit of Azure, but I'm going to do a quick kind of run through of just overall service bus. And then I'm really going to try to dig in and talk a little bit deeper about the queuing system in service bus. So my one joke slide, this is my meme, but just a little Azure background on me. I've been pretty heavily doing Azure PaaS systems for the last 5 years. Service bus has been part of all of them, so I think I have some pretty good familiarity with this system. Just some project for reference. We did a full point of sale system about 5-ish years ago, which is all service bus. We used relays, we used queues, we used topics. So every register in a store was communicating to the cloud, to Azure, using service bus. So it was our entire messaging platform. I did a workflow system in the dental industry that was also very similar story, where we were using service bus as kind of our messaging platform. And then recently in the last year, I've worked on this project called Ion Leaks, which I'm going to talk about here a bunch more, but it is a building water leak detection system. So what that means is, just to give you an example, we work with a local company in Lincoln that they have a long history of building a lot of water valves, which seems like might be an interesting thing, but they partner with us because we wanted to solve a specific issue. So actually I have one of the real guys here, but I don't know if you can see this, but this is a water valve that you would actually put on your water pipes. And I have this building here. This is a incredible condo on Miami Beach. This is kind of the business case for this product that we built. In order to insure a building like this, if there's a leak on the 20th floor and it destroys 19 floors worth of expensive condos, the insurance companies have a problem. So we use some of these other devices. So I have water sensors, which you can see on the screen too, and these are all over these buildings. And when we detect water leaks, we can shut down plumbing stacks inside those buildings in order to prevent further damage. So that's kind of the business that I've been doing here recently, but just a little bit kind of tech side. So this is an IoT, straight up IoT system. It's using something called LoRaWAN, which is really just kind of it's a new standard for kind of long range, kind of wideband devices to communicate. We were looking at some, technical challenges here, mainly, reasons for using service bus, but we really wanted some message durability. We needed to be able to scale. Response time and uptime are important. If a sink starts leaking, we can't wait 20 minutes to shut the water off. We want it shut off right away. And then just a little kind of the blast of the Azure technology we're using. So we're using IoT Hub to ingest messages. We're using Service Bus. I'll talk about a lot more about that. We're also using app services, B2C. We're using API management. We're using Azure Database for Postgres. This is my first time doing not SQL as a .NET shop. So if people have questions about that at the end, that might be interesting. It's been kind of fun. We use Application Insights. We use Key Vault. We use the new app configuration tool, and we use blob storage. I'm sure there's a couple other services I'm forgetting, but that's kind of the primary PaaS stack that we're using to deliver this. All right, so just a little bit of kind of overview on Service Bus. I mean, I'm guessing everybody's heard of Service Bus, but what is Service Bus? So Service Bus is, as a broad category, is really an enterprise message broker that Azure has native in the cloud. It supports the AMQP. So the nice thing is, back in previous years of my development career, there was plenty of people trying to provide enterprise messaging. Most of them were doing it in a proprietary way, and it was hard to integrate systems. It was hard to talk to other people because they wanted their own formats. They wanted money for them and licensing. But we've kind of grown up into a world now where there's some standards on messaging, so we can hook up you could hook up something like a RabbitMQ or something and be able to have these systems work together using both messaging platforms. I'm a big fan that it's really a first-class service in Azure. I mean, it's going to be all over the portal. It's not something you have to figure things out. It's there's drop downs, there's all sorts of stuff. It's been solid from about as long as I've been designing systems in Azure. And I took this quote from their overview page, but I thought this was really important that it's this decouple word is really important for me. Is that that's one of the reasons you use Service Bus or a messaging broker, is to decouple your applications and services from each other. I'll probably talk some more about that later. Just some architectural reasons why I'm a big fan of kind of using these messaging platforms is, we can do a lot with decoupling in our system. Pub sub patterns. We can have publishers and subscribers, and they can be unknown to each other. We can do a thing called temporal decoupling, where maybe we put messages in a queue, but that the in queuer doesn't actually know when they might be processed. So maybe we want to wait. We have a system that wants to wait till the middle of the night when we have a little more downtime to process messages, or we can do things like that, which is nice. We can do some load balancing. This just gives us another knob and dial in our cloud architecture of a place we can load balance. It also gives us some ability to do some ordering. This is not an exhaustive list, but those are some of the bigger ones. I just wanted to talk a little bit. I get this question a lot from some of our newer engineers that are starting to get into this to our Azure platforms, but I kind of break the world down, and Microsoft does a little bit too, into kind of messaging versus events. And so I consider messages to be things with data. So, we're going to talk about this IoT system, and, IoT systems, they're sending us data. It's not just an event. So, that's why I think we work really well with Service Bus in this case. But I think if you're looking for things that are like notifications or state changes or quick little things, I think you're better off kind of starting with Event Grid and Event Hubs. That's kind of differentiation for me on those two. So here's the three kind of primary areas that make up Service Bus. So there's relays, queues, and then topics with subscriptions. I haven't used relays in a while. Relays, I used to use them for hybrid environments. They basically allow you to kind of expose two service endpoints potentially in different data centers or different offices or different places that have potentially troublesome networking, and actually have them both point to a single endpoint in the cloud and have Azure negotiate some of the connection stuff. I learned at one point, I was actually in a meeting at Microsoft, and one of the the main technology drivers for this was Microsoft's acquired Skype a while ago. And Skype always, if you do a messaging client, you got to be good at network penetration and getting around all that sort of stuff. So Azure is actually giving you some of the Skype messaging network penetration tooling by using these relays. I haven't had to use them for a while, but they are pretty powerful if you can. The other cool thing we did on that, the project I talked about for the point of sale, is we would use relays into the stores, but if we were connecting store to store, the Azure relay system would actually teach the two endpoints how to directly talk to each other, like a hybrid connection. So you tunnel out to both sides, tunnel out to Azure, and then Azure teaches them how to tunnel to each other. So it's kind of a cool feature. It has queues. We're gonna talk a bunch more about those, but I mean, pretty, for the most part, standard what you think of a queue, right? We're gonna first in, first out. We're gonna put messages in the queue, and we're gonna pop them off on a receiver. And then for pub sub, we have the topics and subscriptions. This is great for having the center send a message, and we can publish it. And then here we can kind of message out where we have 3 receivers all receiving those messages. So whereas queues kind of give us a one-to-one, this gives us a one-to-many type of networking thing. Talk a little bit about, obviously it's Azure, so we don't have just one tier of things. So we have 3 tiers in Azure. We have the basic, standard, and premium. You can get a lot done with the basic if you're just looking at queues and scheduled messages, but a bunch of the features I'm going to talk about later, we're probably looking at getting in the standard and premium tiers for those. Most of the features are available in standard. The premium tier really starts to get you into the disaster recovery and the Java stuff. So just throwing a little bit of pricing if you're unfamiliar, but it's service bus is not a huge part of your Azure spend, most likely. If you're in your basic, you're getting a nickel per million operations, and standard gets a little bit of an hourly charge, and then start getting some message charges. And even at the premium tier, you're about $600 a month. So that's a nice feature of it. So does anybody have just generic service bus questions, or I'll probably start jumping in here and talking about the queue stuff. All right. Just warning everybody, with not being able to see anybody on the screens, I start to talk faster and faster. So hopefully I can slow down here a little bit, or we'll be done fairly short time. So jumping back to queues. So I'm an old enough developer at this point that I started my queue life in MSMQ on Windows machines. It was pretty interesting. I feel like it's one of the only pieces of software that I know of that was on Windows that I don't think ever changed. I used MSMQ for years. I don't ever remember a version update. Maybe they fixed a bug, I'm not sure, but it always just worked, right? You could in-queue messages locally, you could dequeue them, you peek, you could do all the stuff you wanted, and it just worked. And so I kind of look at Service Bus in Azure as that kind of, they took MSMQ to me for the cloud. And so now I can do the same sort of things just in a distributed system. Architecturally, I think there's some important things that queues help you support just in a generic level. I think if you're looking at doing some event-driven architectures, queues in combination with topics can be a great way to separate your system and allow scale and allow all sorts of things to happen. Just disconnected calls in general, I think, are really powerful at an architectural level. Disconnecting your calls really allows you to, I think it really enforces some good practice for your developers, because you really have to obey a contract, and you can't really cheat around a queue and make direct calls or bad code. You really have to just in-queue your message and have someone else dequeue and work with it. For my use case here, I think it's a very powerful tool for IoT. I'll talk a little more about that as we keep going. It's great for integration. Obviously, if you can, we have this AMQ standard, and we can have people, externally or from another team or anything, they can in-queue messages, we can dequeue messages, we can pass messages around, kind of use it as an enterprise service bus. I also put legacy migration. We use this as a tool if we're trying to kind of tear apart an old system. Anything that we can put on a queue and pick up by some other process or some other foundation is really nice. It also gives us a lot of times we talk about legacy migration. We think about our past legacy that we're going to migrate, but running things through queues actually gives you a great future legacy migration whenever your system becomes legacy, because now we can always, on both sides of that queue, we can start to adapt and change the software without anybody else knowing. So if we have a bunch of different queues and the original sender gets changed to a completely different technology, no one down the stack knows, and vice versa on all the other pieces of the system. I thought I'll throw this in there too, because Azure does have two queue options. So they do have storage queues. I think storage queues are useful for kind of, I think what this would give you the kind of what they would do is they're really great for large amounts of messages. Like you see 500 terabytes, you get unlimited queues, unlimited clients, but they don't have all the features that I'm going to talk about here in the next set of slides. But I think that's kind of differentiation for me. If you're really looking to just dump a lot of messages in a queue and maybe just have them processed and not have to have a whole lot of constraints or anything or any features with that, I think storage queues work really well. They also work really well for just dev testing and things like that. But I've pretty much always leaned towards service bus queues in all of the applications we've built. So inside of Azure, I live in this PaaS world. There's definitely first-class support, and this is not even close to an exhaustive list, but I'm just going to share a couple that we've kind of used in this Ion Links project and maybe a couple other ones. But probably one of my favorite patterns at this point is using queues with Azure Functions. The service bus trigger in code is extremely nice to be able to just wire up a function and have it watch a queue, and away we go. It's been super nice. This is kind of for me replaced. We used to use web jobs for this functionality, so we used to queue stuff in service bus and have the web job come and pick it up. But I think Azure Functions has really replaced that really well. I'm using IoT Hub, like I mentioned before, for our IoT system. This is just a screenshot from the configuration there, where we are basically just every message that comes into our IoT Hub, we are just in-queuing it to our prod telemetry queue in this case, and it just that's it. It works like magic. All our incoming IoT messages are just dumped right into a service bus queue. That was all the configuration we had to do. I also wanted to bring up, this is kind of a future project for me. I'm looking at, I'm starting to really monitor and look at how we can build our services and systems on top of Dapper inside of Azure. And so one of the nice things is Dapper is actually also a first-class citizen, or sorry, Service Bus is also a first-class citizen in Dapper. So this is a little small, but you can see down here in the pub sub message broker that, it's Service Bus sits alongside of, Google Cloud and Amazon and Kafka and RabbitMQ. So if you're looking to build a Dapper system, there's a binding spec here, so you can just plug in your Azure Service Bus queue and use that through your Dapper system. And if you're unfamiliar with Dapper, it's pretty heavily sponsored by Microsoft now. They are looking to kind of build a little bit of portability, so we can build some apps against the Dapper, and it's all built on Kubernetes, and then kind of have a shim and put some of these other products behind it. So in theory, your app could interact with messages to Dapper, and if you move from Azure to Amazon, for instance, we could just swap in the Amazon pub sub broker, and your system should still continue to work. So that's kind of the goal of Dapper. Not to be confused with the Dapper that used to be a database tool. I had to do a little Google searching. I used to give a presentation a long time ago, a little coffee and code presentation on Service Bus, and this is when I first started. This is kind of what I don't know if anybody remembers the old portal, but you can see that this is kind of a view of queues and some other stuff. But there wasn't there wasn't near the functionality that they've kind of worked into Service Bus, or some of it was just maybe you had to discover it wasn't there. So we kind of just created queues and used them like a queue. It was kind of like MSMQ and moved on, but it's really evolved since then. So I pulled this off of the the current Azure dashboard page for a queue, but you can see now that we have a whole bunch of more features. They give some much better telemetry about message counts and all sorts of stuff. But I'm going to go through some of these smaller features, and then we'll get to some of the bigger features as well. But this is the default. The max, you get a max delivery count of 10. In my experience, that has always seemed extreme overkill to have my message retry 10 times on error. Most of the time, if I can't get it, if it's errors out on the first or second time, it's probably not going to be fixed by the 7th or 8th time. So I'd recommend for most people to probably shrink that down a little bit. You can set the size of your queue, the max size of your queue. Message time to live is how long a message can live in your queue before it gets purged out. You can do some. I'm going to go to the next page just to make one more sense. So this is just now where I just copied the create queue UI, but you can actually auto delete. You can actually auto delete the whole queue if you want. So if the queue sits idle for a certain amount of time, so if you're going to have your application create the queue if it doesn't exist, and maybe you have a queue that's not used all the time, you can have it auto delete itself and clean up. It's kind of nice for QA and testing environments if you're having your devs create queues. You can do some duplicate detection, so you can set a window. So we can say any message that's been duplicated in the last 10 minutes. We don't want to just ignore that. You can enable dead lettering when a message expires. And then I'm going to talk more about the partition and sessions later. But then you can also have a queue forward onto another queue, which might be nice if you're going to sunset a queue and you just want to pick up any messages that may still be out in an old system, sending to the wrong queue. So now I'm going to talk about, these are some of the kind of more advanced features that we've used on Ion Leaks, or at least attempted to dig into and maybe use. The first one's kind of simple, but this is I find this to be a very powerful tool of Service Bus, is that we can actually schedule messages in the future. So I put some code in here, but you can see we can actually schedule a message async, but we can send the object and we can set take now and add 10 seconds. So basically we're saying, I don't want this message to be queued into the queue for 10 seconds, and the broker will handle that for you. There's some advantages that you could potentially use. You could potentially say, well, we're gonna analyze some stuff during the day, but we don't want to queue messages. Maybe we just want to queue them in a window overnight where we scale up our servers, or maybe we have a downtime. It's a high demand during the day. We want to process these after night. You could potentially have a delay to wait for another process. I mean, that could be a little bit of a concurrency problem, but it's a thing you can do. For Ion Leak specifically, one of the things we're doing is we have some times where we want to send a message down to a device, but then we also want to follow that up with another configuration message. So we're actually sending a first message, giving the device some time to get set up, and then we'll send a configuration setting 10 seconds, 15 seconds after the message, or the first message is sent. This sessions is the big reason why I've really dug into the kind of depths of Service Bus, and kind of what started me thinking about this presentation at one point. But the crazy thing you can run into, especially in an IoT system where we're processing a bunch of messages, the devices just send them whenever they have status updates, is you can get in a very highly concurrent world where messages are always just coming, and sometimes we need a little bit of control in that world, but it's not always easy to maintain. And we have a scenario which I'll try to describe here, but in our LoRaWAN system, when one of these little devices, so one of these little water sensors, when its battery's put in, it's turned on, the way it works is it just broadcasts to the world and says, hey, I'm here. Anybody want to claim me? And physically in the building, we have these little gateways all over the place. And in order for, to have some network coverage, most likely one of those devices might be able to hit 5 or 6 of those different gateways. And they all spawn off a call, and all those gateways call into Azure and say, hey, can I register this device? So what that created for us is it created some race conditions. We didn't want to have, device one start to write something in the database to claim it while another device was trying to claim it, and then we ended up with the wrong claims. So I started to dig into how do I kind of control that so we can sequence those messages and only do one at a time. And I put in here, there's one way you can't do it. You might be tempted to look in the setting. This is just a clip of a config file, but there's a base max concurrent calls config. You think, oh, I'll just turn that down to 1, and I only allow 1 concurrent call, and I'm good to go. The problem with any of these settings is they are always per instance. So, everything in Azure, we're meant to scale, right? We need a new server pops on and starts processing messages. So, or if you're using things like durable functions or something like that, it's just going to pop more functions. And so you can't really control the concurrency by setting max concurrent calls, because that's really only allowed for, like, for instance, we're using app services. So our first app service gets 5 concurrent calls. The next one spins up, we get 5. So if we set it to 1, we have 1 processing, but the minute another instance spins up, we get another processor, and maybe someone else on my team has decided to add a durable function, and now it spins up, and you can see where we run into some issues there. So this is kind of from Microsoft's documentation, but what sessions really allow us to do is to specify a session key on incoming messages. And it allows us to take a little time slice of the world and basically stack up any messages in the session. So what this diagram is really showing is, we have 4 different sessions here, and they, each one of these sessions is getting locked to a receiver. So if a session ID comes in, it's going to send all of the rest of those queue messages with that session ID that come in behind it into that same receiver, and it's only going to allow you to do 1 at a time. So that has become a really powerful way for us to kind of control a little bit of the concurrency issues. And it's a really pretty simple implementation on the service bus side. So just to put a couple notes, you can't just willy-nilly turn your queue session non-session. It basically has to be created as a session queue, and then everything that's pulling from it has to pull as a session. And then every message that we in queue must have a session. And then I think if you're going to do this, it requires some sort of logical grouping in your problem domain. So in this case, it was really easy for us because this device comes online and it's got a unique device ID. So we can say, oh, excuse me. We can say that, this device ID is my session key, and so it can break those sessions by device ID. And we know that anytime these devices are trying to join, we're going to block them up, and we're going to be able to write the first one to the database successfully, finish it, and then the rest of them are just going to be able to process afterwards and say, nope, we've already registered the device. Back to our little bit of a configuration here. There is a session handlers option class that comes with the session part. So you see this is our kind of message handler option we had before with the max concurrent calls. But this is an important thing as a cloud architect or as the developers, or whoever is kind of setting this stuff up, is you have to first figure out your message wait timeout, which really means a session needs a window of time in which it's going to block a receiver and wait for messages. So this can be a very important thing. You don't want to be this like 15 minutes of I'm going to block a receiver and wait 15 minutes. I mean, it's possible it's a use case, but in this case, we're giving it 15 seconds to kind of wait before it abandons that session and waits for another one. And we're also, in this case, we're setting our max concurrent sessions down below our max concurrent calls, so we don't block that whole processor so it can serve as both sessions at the same time and other calls to other queues as well. You could also solve this problem by using different instances for your different queues. So you could have one dedicated just to session queues. But in our case, we just have a function app that is hooked up to all of our service bus queues, and it's processing them. So the next one is partitioning. I haven't actually, I've dug into this one. We haven't actually used it yet, but I'm kind of holding it as an ace up my sleeve for some potential problems down the road. One concern that we have in the IoT system is as we scale. Right now, we only have about 14,000 devices, I believe, that are hooked to our production system. But as we get more and more devices and we get more and more messages coming in every day, it's very important that the messages that have an alarm or some important event get processed. And so we may look at partitioning our service bus messages based upon some of the incoming message data. So we can actually have a dedicated broker for our messages that have for instance, for a water leak. If we see a water leak, we really want to make sure that gets processed. We can potentially get some higher throughput because we can slow down. Each one will have their own broker, and we can have the normal messages flow through a broker, and then have a higher priority broker for the important messages. Any questions on any of those features? I went pretty fast through that.
I don't see anything on the chat.
Okay. So now I'm gonna kind of wrap up here. Maybe a little faster than I wanted to be, but I will show you a couple other little things that I know about, and then I might actually give you a little peek into our actual system just for fun. So there are some downsides to Azure Service Bus. It is not the world's perfect tool. It still has no local emulator. I put this link to this GitHub story. It's a very, very long thread if you ever want to go through it. Microsoft is still, trying to find a way to fund and figure out a way to build a local emulator for Service Bus itself. I do know that this is my second Omaha Azure meetup presentation. My first one was probably like 3 years ago. We talked about Service Fabric because at the time we were trying to do some Service Fabric. That's not really the case anymore. But one of the things I do know is Azure Service Bus is built on Azure Service Fabric. And so running Azure Service Fabric locally on your machine is kind of an ordeal. They don't really have a virtualization story or a container story for that. And so I understand why Microsoft has struggled to try to recreate Service Bus locally just in some nice little wrapper app. But I'm really hoping that they eventually figure that out or have some sort of way, or maybe they eventually replatform Service Bus out of Service Fabric. But it is one of the downsides. So just a little note on what we do. You might have seen it earlier when I was on my Azure Functions slide, but we actually we kind of name our queues with an environment and a queue name. So, and then what we do is we basically have developers can put their name as an environment. So I can have Andy-telemetry queue, and then the system just looks at the local variable for that, and then we have one big QA namespace in the cloud for Service Bus, and everybody can hit their own development, create their own development queues. It works fairly well, but it's some overhead. Same thing, you have to do that with all topics and subscriptions as well as kind of prepend them. Other strategies would be to have every developer create your own namespace. There can be some cost and an overhead to that as well. But it is I feel like one of the big downsides to people using it. All right. Monitoring, kind of like a lot of Azure, is pretty good. They have, this is a screenshot of dashboard I created, so we can kind of monitor our requests and look at that. That's for like human looking at it. You can also, this is actually an alert I pulled from our system, so I'm actually triggering If I believe it's over the last 6 hours, if our average gets over 40 active messages in a queue, we get alerts. Let's see, I got a question. What's the target store? Not sure. I'm not sure I get your question.
Sam, if you would like to unmute yourself and ask the question, or probably expand more on the chat window.
I'll give you a second if you want to.
You can continue, Andy. I guess he can post it on the
Yep.
chat window, or we can come back to it later.
Yep. This is another feature in app services that I wish Microsoft was a little better about, but you can scale based on the monitoring of a queue. But they really only give you two kind of metrics that you can scale by. You can scale by active messages or just messages. So messages would be all the messages like dead lettering and inactives and schedule and all that. But you could say that, I have one instance that's processing, anytime it gets below 50 active messages processed per instance, that we could scale up. But I haven't really had great success with scaling based upon these queue rules. I've had more success based upon like resources of our app services. I did want to throw too. I talked a little about Kubernetes. They have a this Kata where you can actually hook it up and actually do some better scaling based upon Azure Service Bus. So this would be more powerful if we were using Kubernetes, where we could actually have it scale up more Kubernetes instances based upon number of messages in the queue. Okay, so Sam's asking, what's the target table or storage where the queue is publishing those messages? That's a good question. I don't really. So as far as Service Bus goes, it's a little bit of, I don't really know where those messages are being stored, right? It's just part of the service. So we just create those queues, and we don't have to you don't have to create any extra storage or anything for that, for those. You could have them, there's a lot of easy ways to actually have them kind of duplicated into a storage blob or something like that. But the nice thing about the PaaS and Service Bus is it just handles the storage behind the scenes for you. I'm guessing just like everything in Azure, it's probably like triple redundancy, right? They probably are storing it in multiple places to help protect you. But we're kind of relying on the durability of Service Bus to make sure we don't lose any messages. It's a good question. Okay, and he also asked, how long is it stored? So I showed earlier that the default is 14 days to store a message in a queue. I don't remember if there's a max limit on that. I'd have to look that up. I don't think I've ever had a message live even close to 14 days. So, but yeah. All right. Well, that is actually kind of at the end. So I'm willing to hang out. We can talk some more stuff. I will show, I can show quick too. I might show our dashboard just for fun, but let me drag that over and then we can do this. So we'll see. This is risky, but I'm going to show you guys. This is my actual production dashboard. So this is what's really running in Azure right now for the system. So this was not a made up exercise, but you can see that we have ingested today. We are at 115,000 device messages that have come in through IoT Hub, and all those have been posted to Service Bus. These little water sensors, they check in about every 6 hours for battery. So kind of figure out our device stuff. We also have some other cool devices that do they actually count the flow through water pipes, so we get a little bit more messages from those. But this is kind of cool because you can see our service bus messages and our service bus requests. And then this is down here, we have kind of the CPU and memory of our app services. So this is kind of how I'm scaling. So if we start getting pounded with messages, we start to auto scale and these things start to take care of themselves. You can see that we actually, let's see, last night about 9:22, we actually had an auto scale event. So that's kind of cool. You can see this is a little deceiving. The end devices themselves aren't actually registering with the IoT Hub, so only our gateways are. So you can see we currently have 284 active gateways, but there's, like I said, there's like 14,000 devices behind those gateways. So the devices themselves don't have external internet; they just connect to a local gateway and send messages up to the cloud. And I mentioned we're using I'm using Postgres for the first time. Postgres as a service, which is kind of cool. So.
Did have a question about your scaling out. What scales out in regards to, you said that you're using Azure Functions now that are based on events. Is that what's scaling out?
So that's a good question. I should have probably talked a little bit more about that. So because of some other things we're doing, we are actually hosting our Azure Function apps in app services. So if we were doing like durable, like Azure Functions as a service, right? Like we wouldn't have to worry about that scaling, but we're actually running a bunch of stuff on our app service. So we're running our function app on there as well. So
you have a fixed cost then?
Yes. Yeah. Yep.
Okay.
We were a little worried. I originally did the math on the durable services, and we were a little worried that we would have some like crazy cost overruns. And we have some times where we get kind of bombarded with messages because sometimes devices have trouble joining and they kind of spam us with messages for a day. And so, yeah, this kind of gives us a kind of a flattening of our cost because we can handle those messages. We don't scale very often, like sometimes like maybe once a day, but
yeah. Technically, you can also have auto scaling enabled on app services if that's requirement, but at least to answer to your point, at least the cost is more predictable compared to consumption plan.
Yeah.
I think so. We really got like full production going maybe 6-7 months ago, like to the point where I have enough data to start to actually analyze now if I should go back and just use normal durable functions or if I should stick on the app services route. I'm gonna do that math at some point.
Yeah, one of the questions I've heard from many people most of the times is standard versus premium Azure Service Bus, and the price difference between those two is extensive. Like if standard one is $10 a month, premium is like $600 a month.
Yep.
It scares away most of the people, and they keep asking, why should we be using premium? Have you used premium service bus?
I have not used it. And the funny thing is, you can't even use some of the partitioning isn't allowed on premium. I'm uncertain why, but I've had no issues using standard. So and we're maybe we'll grow to the point where we have enough devices that it becomes a thing we need. But I think we're a long way away.
That's to do with more on when we need very high throughput.
Yep.
Use cases, but for most of the general use cases I have seen, general service bus just works great.
Yep. Yeah, and even for us this is an emergency system, but like 1 second, 1 or 2 seconds, is not really going to prevent much damage. We can't have minutes, but seconds is still okay.
Yeah.
Our time, just networking time is going to be longer than our service bus concerns for throughput. So.
Yeah. If anyone has any questions or comments, or if you would like to discuss anything with Andy, feel free to unmute yourself.
This was a little bit of an experiment for me on a presentation because sometimes it's hard to dig deep into something and that's kind of mundane, but I hope some people picked up some little things to look into or potential little tools you can use later.
Absolutely.
And I just thought I'd bring up I'll bring up our blog again. You can follow Don't Panic Labs on Twitter. It's a lot more interesting than my Twitter. If you're interested, we have some positions posted always looking for some more engineers. So.
All right. If nothing else, I would like to thank Andy once again for taking time out to present today in the group. And thanks to Don't Panic Labs for sponsoring today's meeting. Thanks, Andy.
Yeah, you're welcome.